Hello students, in this video we have second assignment of chapter 10 wave optics. There are 4 questions. We'll address 3 questions in this video and fourth one in next one. The first is state principle of superposition of two waves. We already had it in 11th standard, yet we'll see it once again. The second question is define interference, and next one is define constructive and destructive interference. Fourth one we'll see in next video. So let us start with superposition and interference of two waves. Consider that there is a wave which is having, say, amplitude of 3 centimeter. Let the A be 3 centimeter, and this wave is heating a particle at some point of time. So what the particle will do? As we have learned in 11th standard, this particle will start going up and down. And at any given point of time, the oscillation of particle can be given as A sine omega t plus phi. Considering initial phase to be 0, we can say it is A sine omega t. Right? Assuming that particle is initially at mean position. Now, what is the maximum displacement of this particle? The maximum displacement of this particle is 3 centimeter, right? But what if this particle is simultaneously superposed by two waves? Now there are different possibilities. Suppose one wave is approaching the particle from one side. Hmm. And other wave is approaching the particle from other side. This is one possibility. There is one more chance. It is very much possible that the wave coming from left side hits particle in this way, and the other wave is hitting particle in this manner. So let me label it as situation 1 and 2. So what will happen in situation 1? So in this case, the displacement of particle will be y1 plus y2. What is y1? Displacement due to first wave. Y2 is displacement due to second wave. Why addition? Addition because the waves are incident in such a way that they add into each other's effect. But if you look at second figure, in second figure, if I consider the resultant displacement to be y, then it is y1 minus y2, because they are incident in such a way that they negate each other's effect. So this is basically superposition principle, which says that whenever a wave is influenced by two or more waves, whenever a particle is influenced by two or more waves, the resultant displacement of the particle is vector sum of the displacement due to individual wave. Okay, what is y1? What is y2? These are displacements due to individual wave. And sometimes we take plus, sometimes we take minus, because we are considering direction. So it is called vector sum. So if you want to find out resultant displacement of the particle, you will have to take vector sum of displacement due to individual wave, and that is superposition principle. And this phenomenon is called interference. Uh, a single wave is producing some effect, and presence of second wave is modulating. It is making some alteration in the effect of first wave, so it is called interference. Second wave is like interfering effect of first wave. So the resultant effect produced when you have two or more waves simultaneously superposed at a given point is called interference. Now, what do you mean by constructive interference and what do you mean by destructive interference? Let us consider example of light wave, and with the help of light wave, we'll see what is constructive and destructive interference. So, in case of light, suppose on a screen I have some wave incident which is producing some electric field here. In case of light, light intensity is directly proportional to square of electric field. Okay, so if I consider that this is the amplitude, it is denoted by E. At any given point of time, the electric field intensity is denoted by small e. So what is capital E? Maximum electric field. You may say amplitude. What is small e? Electric field at given point at given time. So how much intensity this point, how much light intensity this point will get is determined by square of amplitude. Amplitude here is E. Okay, now what if there is one more wave which is reaching this point at same time? What should I do then? So in that case, to determine the resultant electric field, first of all, I'll have to take E1 plus E2, or else it may be E1 minus E2. Okay, and then I can say that this E is resultant electric field, this is resultant electric field, and then I can take light intensity as square of the resultant electric field. So constructive interference is the one in which the resultant intensity is proportional to E1 plus E2 whole square when amplitudes are added, when the resultant intensity is more than individual one. Whereas in case of destructive interference, the resultant intensity is less. So we take E1 minus E2. So what is constructive interference? The interference in which the amplitudes are added and as a result, resultant intensity of light is more. And destructive interference is the one in which amplitudes negate each other or they are in opposite direction, and as a result intensity of the resultant wave is less. Now based on this, so many questions can be framed. Let us take one question for understanding it in better way here. Let us consider that in a given light wave, the electric field intensity is say 2 Newton per coulomb. Let me call it wave 1, and then we'll take wave 2 also of identical electric field intensity. So two identical waves we are talking about. What is the data? Data is that E1 is 2 Newton per coulomb and E2 is 2 Newton per coulomb. So what will be the resultant intensity if these two interfere constructively, if these two interfere destructively? So I can say that I1 is proportional to E1 square. That is, what is I1? 4 it will be. And I2 is proportional to E2 square. And for this example, it is also 4. So if these two waves interfere constructively, what will happen? Constructive interference. So how do I find out intensity in case of constructive interference? So we know that in case of constructive interference, I have to add the amplitude. So E1 plus E2 whole square. It means 2 plus 2 whole square Let me call it IC. So IC is proportional to 16. It means that IC is 4 times I1 or IC is 4 times I2. See, resultant intensity is 4 times then the individual wave. Individual wave is having intensity 4, whereas the constructive interference is giving wave of intensity 16. Whereas if I talk about destructive interference, then I'll have to take E1 minus E2, and then it is 2 minus 2 whole square. It means intensity of this interference will be 0. Isn't it strange? Because two waves are falling at a point and then you are giving energy to that point because waves carry energy. So definitely the point is getting energy. Then how come the intensity is 0? How come the intensity is more than 4 plus 4, 8? So the answer is interference is a phenomena in which energy gets redistributed. It's not that you are giving 4 and 4, 8 energy proportional to 8 Newton per coulomb and you are getting 16. You are not producing energy. In this case, you are not destroying energy, but energy gets redistributed. So in phenomena of interference, energy is conserved, but energy gets redistributed. Now there are so many possible questions based on this formula. So watch this video carefully again if you have not understood it. In next video, we'll derive expression for intensity for any two waves. Thank you.